Yeah, I have it hidden. All right. So if you want to get out your backpack, okay, listen, I want you to pull out all of your reference sheets for this test so that you just have them all together. So I'm going to put them up here one at a time. The first one is this one that I meant to put on pink paper, but then it was white. Okay, this is number 1. Cheat sheet number 2 is the one that has the unit circle on it and the hand trig. Okay, so 1, 2. And then the third one that you're allowed to use for this test is going to be your theorems sheet. Okay, plus the fourth one we're going to make right now. Okay, but pretty much they're all ideally on pink paper except for that one. So yes, yes, and then you should have a white. And it's like in my handwriting, not typed. So it should look like this. Okay. So many papers, so much learning has happened, you know?
So much brain cramming. I have it.
All right, did we find them all? Okay, if you're missing one of these 4, I don't mind getting you a copy of it, but let's not do it right now. So if you need one, when we break for you to work, let me know. All right, so let's look at your 4th and final cheat sheet for this test, starting with implicit differentiation. Okay, you are going to use implicit differentiation when you want to take the derivative of an equation that is not in y equals format.
If you need to have your photos taken. Last thing, P, Q, and R. Thank you.
So if it is not in y equals, implicit differentiation is how you're going to take your derivative. Here are your steps. Step number 1, you're going to take the derivative on both sides, d dx. d dx. Any term that started off with a y in it is going to get a dy dx. Okay, watch for terms that need product rule, quotient rule, or chain rule. Okay, remember though, you already have those rules written down somewhere else and we'll practice them today. Then you are going to separate any terms with a dy dx will stay left. Everything else will stay right. If you have multiple dy dx terms on the left side, you're going to GCF the dy dx out. Now, if you only have one dy dx term, you would be able to skip this step. Okay, and then in your last step, step number 4, you're going to divide to solve for dy dx equals. Okay. Now, let's talk about notation. dy dx is the slope for any point that you want. When you plug in your specific point, you need to make sure that you put the vertical line and then the little x comma y of whatever you're plugging in. If you are asked to find the horizontal slope, what part of the dy dx do you set equal to 0? Top or bottom? Okay, top is correct. And then if you're asked to find a vertical or an undefined slope, you would set the bottom equal to 0. Okay, also remember that most of these questions are going to require you to do a substitution back into the original equation to solve. Now, it could be that you set it equal to 0 and you just get a number for x or a number for y. But most of these questions are going to require a substitution. Okay, and you'll see that on your quiz. All right, if you are asked to take the second derivative, okay, I'm going to put 2 stars next to step number 1. Okay, you need that derivative to be as simplified as possible before you take the derivative again. So if you've got x's top and bottom, cross them out and just keep the ones that you need. Same thing with numbers. If you have a 2 top and bottom, cross it out. It's going to make your numbers bigger if you leave extra stuff. Okay, from there, you're going to take the derivative. Almost always, you're going to need quotient rule. Okay, and although this is on another sheet of paper, several groups subtracted quotient rule backwards. So remember, it's ho d high minus high d ho over ho squared. Now, the reason that most of these require quotient rule is because your dy dx is normally a fraction. And so if your dy dx is a fraction and you're taking the derivative, okay, quotient rule would be the rule you would use for that. All right, last little bit of this. For the second derivative, remember it's called d squared y dx squared. That would be the second derivative at any point. If you want to plug in your point, make sure that you include the x comma y in your notation. Lastly, when you're plugging that in, remember you have 3 numbers you'll have to substitute. You're going to have an x and a y, and where the dy dx is, you're going to plug in the slope as well. So if your slope comes out to 5, then whenever you see dy dx, you'll put a 5 into that spot. Okay? Now, if you are asked to write your second derivative in terms of x and y, okay, then you would take your dy dx formula and you would just plug that in so that you would have only x's and y's, and your dy dx would basically be gone and the formula would go in instead. Okay, if you want to know what I'm talking about, look at the very last question on your quiz that I just handed back to you. Okay, the very last question where your second derivative needed to be only x's and y's. Okay, so if you want to put right here, let's do last question on your implicit quiz. Okay, however, I do not think that that is on your test, but I can double check in a minute. Okay, so what I'd like to do is let's try a question on implicit differentiation and see what you remember. So if you will turn, please, to the section implicit differentiation, and we're going to do this question right here, number 12. Of the review? Yeah. So find your test review from last class. We're doing number 12. You do not have any second derivative. We just finished the front of the sheet, and then do you have your review from last class?
Oh, so bad.
Okay, we're about to do number 12 off that.
Maybe you have to like aim it up.
All right, go ahead and give it a shot. Number 12.
Here, you have to do it over here. I just go around.
Okay, for number 12, are you going to need any product rule or quotient rule?
Yes.
Yes, which one do you need product rule for? Okay, what kind of XY? Negative XY, right? So remember that the negative needs to be part of your quotient rule. So when you do, sorry, I meant product rule. So when you do it on this, Okay, your u is going to be minus x. Your v needs to be y. Okay, so make sure you want to build that negative into the equation. So knowing that this term needs product rule, what will u prime be? Negative x derivative is negative 1. And v prime will be the derivative of y, which is dy dx. Okay, from here, you're going to take the derivative of the original equation. Remember, we're doing it on both sides. So this whole thing from here to here. What is the derivative of y cubed? 3y squared dy dx. Okay, then when I get to my product rule, remember, normally it's diagonal plus diagonal. But I noticed that both of my diagonals are going to end up with a negative in it. So I'm going to do negative 1y and then negative x dy dx. Okay, remember that you are multiplying those diagonals together equal to 16, 0. Okay, remember that the derivative of a constant is 0. Okay, let's check our pink sheet. So after we take the derivative on both sides, we want to get all the dy dx terms on the left. Anything else on the right? Who are we moving? Negative y is going to move over to the other side now as a positive 1y. Okay, then on the left-hand side, I want to take the GCF of the dy dx out only if I have multiple terms. Do I? Yes. So I'm going to pull my dy dx out. That's going to leave me with a 3y squared and a minus x in parentheses. Okay, then from there, after I GCF, I want to divide to get my dy dx by itself, which means we're going to put that on the bottom on both sides. So I have dy dx equals 1y, or I guess you don't have to write the 1, but you can, over 3y squared minus x. Okay. Part B says, find the slope of the curve at the point where y is 1. Is that the whole point? A point needs what two things? A y and an x. I have to have both. Where do I go to get the other half of the point? Very good. So I'm going to use y equals 1 in the original equation to complete that ordered pair. Okay, you can't just have half the point because my dy dx has both x's and y's. So my original equation said y cubed minus xy equals 16. And now I'm going to take my 1 and plug that in. What is 1 cubed? Still 1. Minus x times 1 would be what? Just x equals 16. From there, I need to get rid of that 1 in the front, which means that negative x is equal to what? 15. Then that means that x would equal negative 15. Okay, think about it. You're just dividing by negative 1 basically on both sides. Okay, from there, I'm going to take my x and my y together. I'm going to plug them into my dy dx. So dy dx, vertical line, and then x comma y. My x is a minus 15. My y is a 1. And then remember, we're plugging into this right here. So I have 1y is 1 times 1 over 3y squared is 3y squared minus negative 15. And what happens when we minus negative 15? It's really a plus. So this is going to be 1 over, remember, is this correct? 3 times 1 is 3, then square it. Stop doing that. That's bad. Okay, squared first, then times by 3. So 1 squared is 1 times 3 is 3 plus 15 gives me 1 over 18. Okay, if you are asked to write the equation of the tangent line, that's another thing that they'll put on this type of question quite a bit. Okay. All right, last part of this question says, find where the slope is undefined. Look back on your peak sheet. If I want the slope to be undefined, what part of the equation do I set equal to 0? Okay, undefined means I'm going to set the bottom equal to 0. So the bottom of my equation was a 3y squared minus x equals 0. Okay, now at this point, you have a choice. You can solve for x or y. You should do the one that's easier to get alone. Will it be easier to get x or y alone? Benji, you can sit in that chair if you want. Just move the papers onto that desk. Okay, which one would be easier to get alone? X. So I'm going to just add this x across. And so now I have 3y squared equals x. What am I going to use that equation to do? Sub where? Back into the, no, original equation. Okay, remember, you can't substitute back into dy dx because that's where this came from already. You can't like sub it back into itself. That's why we have to go back to the original. So I'm going to put substitute into original equation. So it was originally y cubed minus xy equals 16. And then I'm going to plug that in right here. So now I have y cubed minus, what is my x's substitute? 3y squared. And then I'm going to multiply that by another y equal to 16. What is 3y squared times another y? Y cubed. Very good. Okay, and then I notice, oh, those are both y cubes. That means they're like terms. Then I can combine them. What is 1y cubed? Take away 3y cubed. Negative 2y cubed. What would my next step be to solve after that? Divide by negative 2. 16 divided by negative 2 is going to give me minus 8. How do I undo a cubic power? Take the cube root. Can I cubic root a negative number? Yes, my y is going to equal negative 2. Okay, from here, did the question ask you to find y values or x values? X values. And I have a what? Y value. Now, you have 2 places you can go to find the other number. If you want to go back to the original, you can. But there's another equation already solved for x that's a lot shorter. Look right here. Remember, x is 3y squared. So if I now know that my y is a negative 2, then I know that x is going to be 3 negative 2 squared. And negative 2 squared is 4. 3 times 4 is 12. Okay, which is not an answer choice because I didn't read my own instructions. So x equals 12, make it answer. Okay. But remember, you could plug back into here. Your math is just going to be harder than picking the little short sub equation. Can we do it? Yes. Uh-huh. Because it's a 1 take away 3. So if you do 1 minus 3, it comes out to 2. You're like combining one term. Good? All right. Flip your pink sheet over, please. Okay, the other sort of big topic on this test, besides taking derivatives, is going to be related rates. So let's run through our steps and then we'll do a question together. Okay, for related rates, you're going to set up your find, given, when, and your equation. Okay, remember that your find and your given are rates for how fast things are changing. The find is the unknown rate. The given is the known rate. Remember that the plus or minus should be assigned based on whether it's an increasing quantity or a decreasing quantity. So use a plus for an increasing, or if you want to put growing quantity. So if the base is increasing at a rate or it's growing at a rate, you should let it equal a positive. Okay, versus you would use a negative for a decreasing or shrinking quantity. Okay, also think about things like if an ice cube is melting, if a tank is draining, okay, all of those would also give you negatives. Okay, your when is a particular value for a changing quantity. We've talked about that. And then for your equation, I've given you all the same formulas that you had in your notes, okay, down here at the bottom. So you will not be able to use your notes for related rates, but you have all the formulas you need right here. Okay? You get to use this cheat sheet. You don't get to use the notes that had all the formulas on the front. Yes. Okay, then before you take the derivative, you are going to plug in any fixed constants to the equation. Okay, what I mean by that is like if you have a ladder that's 25 feet long, you don't need to give that a variable. So if it's something that is a fixed constant, you can plug that in before you take the derivative. When you do take the derivative, this is going to be ddt. Okay, because these are word problems taken with respect to time. Okay, then remember that all terms, when you take the derivative, they're going to get a dl dt, or a dr dt, or a dv dt, and then I'm just going to put dot, dot, dot. Okay, so it doesn't matter what you're taking the derivative of, okay, unless it's a t for time, it gets a d crap dt. Okay, also watch out for any product rule or quotient rule. Okay. All right, step number 2. You are going to plug in all of your givens and your whens. Okay, after you take the derivative, you can plug in all of your givens and all of your whens. If you are missing any extra information, remember you go back to the original equation to find those details. Okay, and then you'll solve. For your units, if it is a length, like a radius or the side of a triangle, it would be units per time. What about if it's an area's rate of change? Units squared per time. Okay, and then the last option would be if it's a volume, that would be units cubed per time. You're welcome to keep track of units the whole time in the question, or just go back and put them on the end, which I think is easier. Okay, when you're ready, your packet's numbered kind of crazy, but find number 14 with an asterisk on it. We're going to do this one.
Like at 14.
I know, I think there's multiple, but it is. Okay, and then if you don't have a calculator, we go get one.
Oh, yeah, yeah, yeah. Still have it?
Huh? Yeah.
You just joined us.
So,
Yes, it's social security.
why? Yeah, someone's gonna steal your identity. Oh, that's okay. You're fine. I didn't mark you absent yet.
Oh, it's because we did the SAT stuff. We were doing SAT stuff.
And you don't have it memorized?
I have mine memorized. It's not.
What is it? Prove it.
So you have it because like.
I was joking. Like I'd steal your identity.
It's not the actual like security card. It's like
I see. I don't think we have access to your social.
Good.
Yeah, I mean we can check like your address.
You're not one of them guys.
You would trust me with your
Hey.
Good. Good luck to the game. All right.
Don't suck.
Okay, we're gonna draw a little picture, but first, okay, give yourself a little compass. Okay, never eat soggy waffles. Or never ever smoke weed, however you want to remember it. All right, here we go. Okay, it says a railroad track and a road cross at right angles. So let's do road, railroad track. Okay, then it says an observer stands on the road 70 meters south of the crossing. So here's the guy. Okay, he's south of the crossing. Okay, then it says he watches an eastbound train traveling 60 meters per second. Let's put the train over here. Okay, before we keep going, I want you to reread the question and label the two things that they've given us so far. So it says we have a railroad and a guy. Which side should get a number, not a letter? The guy, how far away is the guy? And is that changing? No. So fixed constants you can plug in right away. The guy's looking at the train, but he's not walking anywhere. Okay, then the train, is it moving? Then its distance is going to be changing. So I'm going to call it X. Okay. Then it says, at how many meters per second is the train moving away from the observer? 4 seconds after it passes through the intersection. So draw a third side to your triangle, which is how far away the train is from the guy. Okay, and we're going to call the distance that they are apart from each other C. All right, fill in your find given when. Okay, think about what are we finding? What are we given? What's our when? Okay, 70 is part of the picture, so you don't have to put that in anywhere.
No, I was so confused.
So what is it asking you? How many meters per second is per train?
What's funny is that, yeah, like, kind of like it's for.
So which side?
No, you
We're
don't
finding how fast that's on.
you're not getting my.
So call it the right? Okay, then for your given, they tell you how fast the train is moving. How fast is it going? So that the dx is 60. Okay, and then for your when, what is this? Okay, then think about it. For the three sides of the train, think about what equation.
Yeah, the first one works.
What is the M? Let's use C since that's
I'm never gonna finish that.
just to kind of keep all the same letters, you know? And then even here, for your A squared plus B squared equals C, we're gonna use this. So it'd be 70 squared plus x squared. You know what I mean?
Yeah.
So basically, this is a right triangle, but you want to use the letters and numbers on that triangle. So rather than doing a squared plus b squared, you want to say 7 squared. Yeah, so that way when you take the derivative, you're not like, what's the a and t? I only have a dCdt and a dx. You know what I mean? Because I fixed all this x since it's usually if it's up and down, I do y. This is how fast it is. So this x is how far the train goes, right? And it says right here how fast it goes. It says the train is so, well, hold on. So, please, let me fastest. That would be so think about x would be how far away the xct, how far away the different x how fast that would be from here.
I'm gonna pick
Well, that green theorem is just the shape that you have that relates to the size function. All right, let's see how we did. What are we finding? dCdt, because we don't want to know how far apart they are. We want to know how far apart their distance is changing. That's dCdt. What are we given? Okay, dx dt, very good. And how fast is the train going? 60. Okay, for your when. Okay, this is very important. You'll have to do this on your test. It says 4 seconds after it went through the intersection. So let me remind you, the train is going 60 meters per second, and I'm going to wait 4 seconds. How far will the train make it in 4 seconds if it's going 60 meters per second? 240. So I'm going to put then x equals 240. Okay, think about that one more time. You know how fast it's going per second, then you would times it by 4 to see how many would go. It'd go 60 in the first second, 60 more, 60 more, 60 more for all 4 seconds. Okay, then for your equation, we're using Pythagorean theorem. So it'd be 70 squared plus x squared equals c squared. Okay, from here, you need to take the derivative. Okay, so let's do that up here at the top. What is the derivative of 70 squared? 0. What is the derivative of x squared? 2x what? dx dt. What about c squared? 2c dc dt. Okay, from there, you're going to go plug in all of your whens and your givens. So for my when, I know my x is 240. I know my dx dt is 60. And then when I get to my c side, I notice that I don't know that. So look back at your pink sheet as I plug in. Okay, I'm expecting not to know dc dt because that's what I'm trying to find, yeah? Okay, but c, I should already know that. So look back at your original triangle. If I know that my x is 240, and I know that my other side is 70, can I go back and find this missing side? Using Pythagorean theorem, not the derivative of it, but the original. So in your calculator, you're going to find c using 70 squared plus 240 squared equals c squared. Good. Okay, once you find that distance, go back and plug it in and solve for dc. So if let's say it's 2 calories every word. And I'm 10. How many calories did I have to get 3 points and I had 10, right? So now let's say I'm running 2 miles per hour and I run for 5 hours.
We're both wrong.
For 5 hours.
Dude, I was about to think, hey.
So basically, how many per hour and time does it stay on? The same thing, how fast the train's going? 60 meters per second, and how long am I doing?
I guess we both gotta go follow.
So then it goes 60 times 4.
And there. Oh, I got it. Bear fit too.
No. Oh. Did you the water
No, it's much more concentrated. It's like saying like eating 50 apples is the same as eating 2 games. I'm making my way to bed.
You both have to go what? Oh, wow. That would be very sad.
This can go back. Wow. I'm in and out. Like I'm in and out. Good one.
All right, when you get to here. Okay, let's finish it up. Okay, ready? We're going to divide the 500 across and you'll have your answer for part A. So 28,800 divided by 500 is A. All right, go down to part B. Okay, part B says, how many radians per second is the angle the man is watching the train from changing at the same instant as part A? Where should I put my theta? Which corner? The bottom one, where the guy is. This is his angle that he's watching the train from. We're going to call it theta. Okay, also keep in mind that you can only use SOHCAHTOA on right triangles. This is a right triangle. So change your find and your equation. Okay, if we want to know how fast the angle he's watching the train from is changing, we're going to call it d theta dt. And now you're going to have to pick for your equation between sine, cosine, and tangent. Okay, let me remind you of what we decided last class. You always want to pick if there's a side not changing. You always want to pick that. So out of these 3 sides, which one do I for sure want to include? Is 70 the opposite, adjacent, or hypotenuse? Okay, this is the adjacent. I know I need an A, so I know I do not want so. Okay, out of ka and toa, I want whichever number for dx dt or dc dt is going to be easier. Okay, so my dx dt came out to be 57.6. What was my dx dt though?
240.
Oh, 60. So which number is nicer? 60. Then let's use this side, which would be the opposite. So which of my functions, sine, cosine, or tangent, is going to have the opposite and the adjacent in the same equation? TOA. So it's going to be tan theta equals, opposite is going to be x over 7b. Now, the way that that's written right now, it looks like it needs quotient rule, but remember, it doesn't unless these are both changing. So I'm going to rewrite my equation. to make it very clear that I do not need quotient rule, I'm going to do 1 over 70x. All right, take the derivative of that for me. Starting with tangent. If you do not remember your tangent derivative, remember it's on the one with the circle. What'd you say? The answer is right. Good job. Okay, take your derivative.
Okay. Whoever gets it right.
So think about this is so when I take the derivative, I'll do 1 times 1 over 70, and then I'll power my x down to 0.
Oh, that one. That's what way I didn't know.
Yeah.
Take it, Mom. Hey, come on.
So that's your left side. So what's the derivative of 1 over 70?
You kind of love it. I'm just saying, thank you. No, it's not. You do what?
But remember, it's
I do it, and I want you to do it. They kind of love it.
Okay, your derivative should be secant squared theta d theta dt. And then on the 1 over 70x side, what's the derivative there? Very good. Okay, the derivative is just the number in front of the x. The x will drop off to a 0, but then you have to attach the dx dt. Okay, from here, for the secant, okay, this is the part that we covered last time. You have to use your SOHCAHTOA to know what to put into that spot. So look back at your pink sheet. Okay, they're all pink, but okay, pretend. Okay, secant is which one flipped? Cosine. So listen, if cosine is a over h, what will secant be? H over a. Very good. So my h over a is going to be 250 is my h over 70. H and A is hypotenuse over adjacent in the original triangle. Okay, then equals 1 over 70, and my dx dt is how fast the train was going, which was a 6c. Okay, from here, you want to get rid of the fraction that's multiplied in front of your d theta dt. How do we do that? We talked about it last time. Multiply by the reciprocal. So I'm going to times by 70 over 250 squared on both sides. Okay, that's going to cross out all the stuff in front of the d theta dt so that you'll have your answer. Make sure you use the pretty fraction in the calculator to pick an answer. Okay, type that into your calculator. Also, someone in the other class asked, can we cross the 70s out just to type less? You can get rid of one of the 70s, but if this is a 70 squared, it'll make your answer wrong if you cross them both out. So I would say just don't do it. Okay.
That is B.
I think. Oh, it is. Okay. What did you get?
Bring the bird. Nobody was before. It's three because you guys are happy about it, not shaking on it.
Yeah, you should have gotten which one? Make sure you divide it to match an answer choice. Just do regular division. What'd you say your numbers were? Over. Okay, yeah, it is B. Good. All right, what I'd like for you to do, we're just going to do 2 more questions together. Turn back to number 15 that I said we do last class. Okay, however, you would think that would come after 14, but it actually comes before. East one. Half of it is, half of it isn't. Yep, right there. All right, start it off. Here we go. Yes, but the water is dirty.
He's like, shit, I don't think I'm right on it.
Oh, Bill, will you take the pass? All right, so let's do this one here. Yeah. All right, so to find given one. And now let's read through it and fill them in as we go. So read through the whole thing and then tell me what we're finding. You can tell me words if you don't know. All right, ladies, sausage ready to get it. Are you good?
What else?
All right, we're going to get started. Find given one.
Fine.
Well, let's call it DS. Want to know how fast this surface is? Okay. What are we doing? Do you need to know how fast something else is? Right. So what would that be? An increase positive. Okay, now notice that this increase for how long it is, so let's put X equals X. Okay, and then figure equation that you do. So let's start with, if I want this, the surface area. Put S equals 6X. And then let's take the derivative. What would the derivative of S? No, my was very So what about the other side? It's a 6X squared. We're taking the derivative. Good. And then from there, when I'm going to plug stuff in, notice. Yes, you see what I'm talking. No X is 10, but I don't have to. So let's look back in my given. What did they give me? So I'm going to have to go outside of that, and we'll use that to figure out what dx means. So what's the derivative of x? Okay, so we kind of did a little bit of like that. We're going to take all different numbers. Maybe t equals that be.
Cut it in half, take the powder out. That'd be so.
3, so what's that x? I just don't want to wait.
Oh, they don't even teach it.
Right? Like that. 3 times 10 squared.
Actually,
Now we'll do this 3 times 10 squared. So I find and then you're going to divide that. And you can Yep.
Making making this holiday. About getting this. Sometimes holiday meetings. You want to like. I want to.
A little bit better. Y'all missed some of this. Or it just yeah. So good. So you're that's DVD. Oh, okay.
Yeah.
We have a little bit wrong. Okay, so you have two different equations here, yeah. So you put DVD. And then I got. Oh, okay.
Yeah. That's your receiver.
Yes.
You just be down to one.
Yeah.
Why would you need to run if you can drive the Hellcat?
Okay. Yeah. So it's a square. Yeah. Okay. Good. Now you know this. You know X.
Yeah.
Right. Tell us the edge of the cube is 10. Yeah. The problem though is we still don't know yet. We're talking about we know DBDT. That's like a solve for that. Very good. All right.
Yeah.
Okay, for this one. Okay, you are finding what? Okay, we want the rate of change of surface area. Okay, so we're finding dSCT for surface area. Okay, and then what are we given? How fast what is changing? So that'd be dVdt is 20. And then they tell you that the edge of the cube for your when is 10. But do you see how they're using an x here in the equation? So I'm going to put x is 10. All right, then for my equation, they gave me two of them. Okay, but let's start with surface area. If I know that the surface area of a cube, let's put equation, is 6x squared, what would the derivative of that be?
12x.
Yes. Okay, so ds dt equals, and then 12s, you were right, 12x dx dt. Okay, and then when I get to here, keep in mind, this is what I'm solving for. I know x. What's x? 10. So we're 12 times 10, but then, we don't know what dx dt is. So you end up having to do a little mini side quest, basically, to find what your dx dt is to know what to put there. What other information did they tell me stuff about? Not just surface area, but also volume. They told me that volume is x cubed. Well, then I'm going to take the derivative of that and hope that it will help me figure out dx dt. So if volume is x cubed, what's the derivative of that? 3x squared dx dt. And then they told me that dv dt is how much?
20.
So 20 equals 3 times 10 squared dx dt. Okay, remember, you do the exponent first. So 10 squared is how much? 100 times it by 3 is?
300.
So I have 20 equals 300 dx dt. And then I'm going to divide that 300 out of the way. So dx dt is going to equal how much? 2 over 30, which will go to 1 over 15. Okay, and then from there, you can plug it in right here. Okay, so you have to kind of follow the breadcrumb trail until you get there. Okay, then in your calculator, 12 times 10 divided by 15 is 8. Okay. Maybe I give up for today.
That's a good idea.
All right, do more of your review on your. Great question. It's surface area. So it's instead of